This lesson is for MEA 301. Today our focus skill is going to be to compute the perimeter of polygons with all side lengths given. We're actually going to begin with a review skill here of finding the length of a segment. So here in this first example problem it says find the length of segment AC. Now because both of the parts are given and I want to find from A to C, all I need to do is add both AB and BC together. So I have 5 plus 24, which gives me 29 centimeters. Make sure you're using your units. Now problem 2 is a little bit trickier because here we're asked to find the length of AR. It's a missing portion of this entire segment. So this is a little bit trickier because you can't just add up all of the parts. Now problem 2 is a little bit trickier because here we're missing a portion of our segment. We're asked to find the length of AR, which is shown here with a variable x. Now in order to do this, you want to think logically through this and kind of problem solve. If you look at how they give you the entire length of the segment, you know then that the parts, the individual parts here, need to add up to 33. So I can actually set up an equation here. If I take 12, this length here, and I add the length of x and 15, that's going to equal 33. So now I simply solve this equation. I can simplify these like terms here and make that x plus 27. And then to solve for x, I simply subtract the 27 on both sides. So I end up with x equals 6. Now, of course, we want to make sure we have units. So the answer here is 6 centimeters. So AR, that segment length, is 6 centimeters. I'd like you to pause the video now and try problems 3 and 4 on your own, and then you're going to check those in when you get your notes checked off. So our focus skill today is going to be to find the perimeter of polygons. Now we actually have some experience with polygons because that was our MEA 201 skill. Now here we are asked to find the perimeter of this particular figure, and if you remember from MEA 201, this figure is called a kite because it has two consecutive sides that are congruent to each other. So these two sides are congruent, these two sides are congruent. Remember what these little hash marks mean. So here if I want to find the perimeter, since this segment is labeled as 2 inches, this must also be 2 inches because it has the same exact hash marks. And because this segment is 3.5 inches long, this must also be 3.5 inches long. So now I'm just going to add all of the parts. Now if I add all of those parts together, I end up with a perimeter of 11 inches. So I'm going to write 11 inches equals P, which stands for the perimeter. Now the second example here is actually a little bit trickier. We have to do a lot more problem solving here to find the perimeter. Now I'm going to highlight the parts that we do know. We know that GH is 2, AB is 10, and then BH, I'll do that one in blue, is 8, and DE is 3. Now that's a lot of the pieces that are missing here if we're going to try to find the perimeter, because remember for perimeter we have to go all the way around, so we need to know all of these parts, those lengths as well. But here we actually can do a little bit of problem solving, like I said, because we don't need to know the specific amount, that length of GF or that length of AH, because if I look to the right here with the blue segment, I have a vertical line here, 8, and another vertical line here, 3, that represents the entire length vertically here. 8 plus 3, that means that the height of this figure here is 11, which means that over on the other side, AH and GF, even though I don't know their individual lengths, I know that together they add up to 11. Now the same thing goes as well horizontally. If I look at this horizontal line, A to B and G to H, that length is 2 and 10, which means FE and DC must also add to 12. 2 plus 10 is 12. Now I'm just going to work on finding all of those totals put together. So I will take this sum here, 2 and 10 gives me 12, plus this 8 and 3, which was 11, plus this 12 here, because this segment length and this segment length must add up to 12 as well. And then the sides here, AH and GF, must add up to 11, so that's 12 plus 12 plus 11 plus 11. So altogether, my perimeter here is 46, and I don't have a unit on here, so I'm just going to write 46 for the perimeter. Now I would like you guys to try 6A and B on your own. They are a little bit trickier, so go ahead and try that one, and then when you get your notes completely finished, we can go over those and check to make sure you did them correctly. Okay, next up is our level 3 question, our focus and context questions. So this is when we're going to apply the idea of finding the perimeter of polygons to word problems. So let's start with our first word problem, number 7. A Major League Baseball diamond is a square 90 feet long on each side. If Albert Pujols hits a home run, how far would he have to run around the bases? So this is where you're going to have to realize that this is a perimeter question. They give you the shape, they tell you it's a square, so we know that all of these sides here are going to be the exact same. And we also know that each side length is 90 feet long. So we can just take 4 times 90 to find that perimeter, and that would represent the length that he would have to run around the bases. So we have 360 feet. Number 8 states, given the triangle below, solve the equations to find the length of the sides of the triangle. Then calculate the perimeter of the triangle. So there's actually 2 steps here. First, we're going to have to solve the equations so that we can find each length of each of the sides. So here I have a variable a, then b, and c, which I need to solve for over here in order to plug in that value to find the perimeter. So there are 2 parts to this question. So let's make sure we can solve for a correctly. Now a lot of times I will see students who add 15 here, even though the 15 is actually positive. So in order to isolate the a, we need to make sure we subtract 15 on both sides. When we subtract 15, we end up with negative a equaling negative 8. And to get rid of that negative, remember there's an invisible 1 there. To get rid of that negative 1, we need to divide by negative 1 on both sides. And we end up with a equals 8. Solving for b is very similar. We're going to subtract 13 again on both sides of the equation. That cancels here, and I'm left with the negative b, so I bring that negative b down and bring down the equal sign. 9 minus 13 is negative 4. Now again, when I try to get rid of that negative 1, this is attached with multiplication. This is negative 1 times b. To undo that, I need to divide by negative 1 on both sides, and I end up with b equaling negative 4 divided by negative 1, which is a positive 4. Finally, for c, this is a pretty standard question here. I think in one step you guys would all be able to get that. We just subtract 5 on both sides. We're left with c equaling 5. Now we're going to take the values for a, b, and c. We're going to plug them back into the triangle here. So I have a is 8, b is 4, and c is 5. So I'm going to find the perimeter by adding all 3 of those sides. So I have a total perimeter of 17 units. All right, now number 9 says, Frank and his father planted a garden in their backyard. To protect the garden, they would like to build a fence around it. If the length of the garden is represented by the expression 8x plus 2 feet and the width of the garden is 5x minus 3 feet, we're supposed to write a simplified expression for the amount of fence they would need to buy. So let's just draw a diagram first. That's one of the most helpful things that you can do, is create a diagram to begin. So I have a rectangular garden. One of the side lengths is 8x plus 2 feet long. The other side length, the width here, is 5x minus 3 feet long. Now if I want to figure out how much fence I need to go all the way around this rectangular garden, and I need to add up all of the side lengths. So this is a perimeter question. This is an application of perimeter. So I need to add 2 of the 8x plus 2 lengths and 2 of these 5x minus 3 lengths. Now you can, if you want, write a very long expression that looks like this and just combine like terms, but I want to do this a little bit quicker with you. So I have 2 of these, and I have 2 of these. So instead I'm just going to say 2 times 8x plus 2 plus 2 times 5x minus 3. This is twice the length plus twice the width. So that's an expression for the perimeter of a rectangle. So if we want to use our distributive property here, we would distribute that 2. We have 16x plus 4. Now I would distribute this 2 here, and I have plus 10x minus 6. And then if I combine like terms, the 10x and the 16x would combine to give me 26x. And this positive 4 and the negative 6 here would combine to give me negative 2. So I have 26 minus 2. This is the expression for how much fence he needs. So this is the amount of fence Frank and his father need. Now I almost forgot the units. Make sure we're adding the units here. This is in feet. All right, let's move on to number 10. Number 10 says the length of a rectangle is 8 feet and the width of a rectangle is 5 less than twice its length. What is the perimeter of this rectangle? So let's first draw a diagram, because that's really helpful whenever you're dealing with a perimeter question. So I have a rectangle here, and one of the side lengths is 8 feet long. Now the other side says the width of the rectangle is 5 less than twice its length. So this is an expression that we need to try to write and figure out what that width here would be. So if we read this, 5 less than twice its length, sometimes I'll have students who write 5 minus 2 times that length. And this is not the case. Whenever we say 5 less than a value, or when you're taking away something, you're actually subtracting that amount from twice its length here in this case. So we would take 2 times the length, so we don't want to use this expression. We're going to take 2 times the length, 8, and subtract 5. So we end up with positive 11. So if we want to find the perimeter of this rectangle, remember we have to double 8, and we have to double 11. We would take 2 times this amount and 2 times this amount because they have 2 sides that are the same. So that's just a shortcut instead of adding 8 plus 8 plus 11 plus 11. So we have 16 plus 22, which gives me a total perimeter of 38 feet. All right, this is our last context question. In number 11, it says that the hexagon below has a perimeter of 92 millimeters. Now in this case, it's a little bit different than the last problems we've been working on because here they actually give you the perimeter. So I'm going to list that important information here. The perimeter of this figure is 92 millimeters. We're supposed to write an equation to express the perimeter, and then we want to solve for x. So if I look at the perimeter of this hexagon here, I would need to add all of these sides here. Now I already know the outcome of that perimeter. That perimeter is supposed to equal 92 millimeters. So that's how I'm going to set up my equation. I'm going to add all of the parts. So I take x, that side length that we're solving for, plus the known side lengths, 15, 12, 17, 10, and 18, and I set that sum, so this is the expression that would give me the perimeter, I set that equal, in this case, to 92, the given perimeter. Now if I combine my like terms here, so I can combine all these constants and write that as x plus 72, I end up with an equation that's a little bit easier to solve. X plus 72 is equal to 92. So now I'm going to subtract 72 on both sides, and I end up with x equaling 20. So this is the value of x, that missing side length. Okay, you guys are going to try now questions 12 here through 16. They're very similar, so if you get stuck on any of those, make sure that you do, reference our notes. So complete those, please, and pause the video. Okay, we're going to finish off the video lesson with our extension skill, our level 4 questions. Here we're working on finding the area of rectangles. So in this case here, I know that most of you have already used this formula many times, but the area of a rectangle is given by the base times the height. Now in this case, we can also use length times width, whichever one you're more comfortable with, but either the length or the base can be represented with that 19, and the height or the width can be represented by 4. So I would just take 19, multiply that by 4, and I end up with 76. Now I have to make sure I put my units on here, and anytime you're using an area, your units should be squared. So in this case we have centimeters squared. That's our unit. So I have an area of 76 centimeters squared. Now the last question that we'll work on together, number 18, is pretty similar to a question that we already saw. Here they tell you that the width of a rectangle is 10 feet and the length of the rectangle is 4 less than 4 times its width. So let's draw a picture first. This question is different because it's asking for the area, but we're going to practice one more time how to rewrite an expression such as this one here, 4 less than 4 times its width. So I'm going to start first by showing that one of the sides of this rectangle is 10. Now the other side, it says, is 4 less than 4 times its width. So I need to take this width here, I need to multiply that by 4, and then I need to subtract 4. We're going 4 less than that number. So if I end up simplifying here, I end up with one length of 10, and the other length here is 40 minus 4, so 36. Now if I find the area, remember area is base times height or length times width, either one, you would end up with 36 times 10, so we have 360, and remember your units here should be squared, so we have square feet. 360 square feet is the area of this particular rectangle. Okay, you guys can finish off now problem 19 and 20. These are just some extension skill questions where you're going to combine like terms, and number 20 is very similar to number 18, the one that we just worked on. All right, nice job. Go ahead and get your notes checked in and move on then to skill sheet 1.